Number 2 wants us to find the integral of root 9 minus x squared from negative 3 to 3. So as you should know, whenever you're finding a definite integral, what you're really looking for is the area bounded by that curve and the x-axis. So it's really important that you understand what this curve looks like. Otherwise, you're going to have a hard time with this problem. You might try to do maybe a u substitution or something along those lines, but honestly, you really want to know what this graph looks like because it makes the problem a lot easier. So here it is. Basically, this is the top half of a circle. It's the graph of a semicircle. The graph of a semicircle is going to look like y equals the square root of a squared minus x squared, where a is the radius of the circle and it's centered at the origin. So once you realize this, you can start to visualize what this function is going to look like. Since the radius is 3 and it's centered at the origin, we can go out 3 spaces and draw the top half of that circle. Now, the reason why looking at this problem visually is so helpful is because you should know what the formula is for the area of a circle. The area of a circle is pi r squared. It's a pretty common formula, and I think it would be reasonable to expect you to know that. Now this is just a semicircle, so it's just half that. So area of a semicircle would be 1/2 pi r squared. And so essentially that's what we want. We want to find the area under this circle from negative 3 to 3, which just so happens to be the boundaries of that circle, so it works out really nicely. Here's negative 3, here's 3. So the integral from negative 3 to 3 of root 9 minus x squared dx is simply the area underneath that curve. So 1/2 times pi times the radius, which is 3 squared. 3 squared is 9, and half of 9 is, well, just 9/2. So we get 9 pi over 2, and our answer is D.